Good evening everyone. Today we are going to do the daily Leetcode challenge of 4 March 2023. That is question number 2444. Count subarrays with fixed bounds. It is a hard question but it will be medium or easy if you watch this video carefully. The question is saying that we are given a nums array and there are two integers minimum k and maximum k, and we have to return a fixed bound subarray which has a minimum value minimum k and a maximum value maximum k, and we have to return the number of subarrays possible, not the subarrays themselves. And what is a subarray? It is a contiguous part of an array, that is a continuous part. So move on to the example. If we see here, the answer is 2. How it is coming? They are saying that minimum is 1 and maximum is 5. That means when you move to the array, you see that minimum is there. Okay, then this is fine because it is in between 1 to 5. Then 5 is there. Okay, so you return 1. Okay, very good. When you come here, it is also in continuous. So you can return another array. That is 2 ways possible. But when you come here, it is out of bound. So it is not possible. And 5 alone is not possible as well because it does not have 1. So answer is 2. So let's say if you have 1, 3, 5, 2, 7, 5, 2, 3 or 1. So in that case, up to here, 135 is one array, 1352 is second array possible, and after that this is not possible. But when you come here, you see that it is maximum. Okay, you move on. You see 2 is in between 1 to 5, that is also right. Then this is also between there and then this is also right. Then this is there. So you will get another possibility, that is answer will become 3 in such cases. So that is how you are checking. But how do we approach this question? So for approaching this question, you must solve some different test cases and then you can think of an optimal choice. The approach I came up with was we will have to get the range, and there is no certainty that maximum bound can come later on or minimum bound can come first, or minimum bound can also be here after this 5 and maximum bound would have been here. That can be the case also possible. So we have to deal with something with indexes so we can get the array sizes or the number of arrays. So here our number is given. Let's take an example: 2 1 3 5 2 7 5. 2 1 3 5 2 7 5. This is our array given. The what is the let's mark the indexes as well with a different color, that is 0 1 2 3 4 5 6. These are our indexes. So what is happening now? The minimum k is this and maximum k is this. So we have to get the bounds. So what will be the bounds? Let's say we have a boundary called minimum boundary and maximum boundary. That will give us the index of the minimum k and maximum k. Let's initialize them with -1. Also we need to get a bad boundary. What is a bad boundary? Bad boundary is the value which is not in the boundary. In this case it was 7. And how do we get the bad boundary? If number is less than minimum value, minimum of k, or our number is greater than maximum k possible, then we get a bad boundary. And bad boundary will also be initialized with -1 initially, but then we will update it with index. So what we will do, we will apply the approach like that every element to its right is possible, that is every element to one of rights is possible until here, and after that towards its right it is not possible. We have to find a continuous array and we have to move along a side. So we are moving towards the right side, so we will think of approach in that direction. So what we do is we will update our count by what formula? We will see which is bigger, either 0 is bigger or the difference of bad boundary and the minimum of these two, that is whichever is coming first should be come here, that is minimum of min b and max b. Let's write mb and max b, minimum of these two, so we can get the leftmost index, that is the starting point of the subarray. That's why we are doing this, and we will take the common among these, we will take the maximum of this to our count. So let's make it a dry run for this approach and see whether it is actually right. So let's move on here and see. What I said is that first we will we will make variables like min k, min boundary is -1, max boundary is also -1 initially. And we will be running a loop till O of n, that is the size of the array. And our bad boundary is also initialized with -1. So now what we will do? we will get the count formula we have written previously. So we will start with 0. We will check whether it is out of bounds. No, it is inside the bound, that is it is between 1 and 5, so we won't do anything. Then we will update our minimum or maximum. No, because it is not equal to minimum or maximum either, so we do nothing, we add 0 simply. Why 0 added? Because our formula is this. So what is maximum? 0. 0 and minus 1 comma minus minus 1, that will become plus 1 ultimately, so that will come out to be 0. So first iteration will give us 0. When we move here, our minus 1 will get updated to 1 index, and we will see that rest of the things remain same. So in that case, when you get the count, how will you get the count? Which is maximum between 0 comma, what is minimum among these two? Minus 1 or 1? So minimum is minus 1. Then again you will get a plus 1 here because bad bound is still minus 1. So we will get 0 again. When we move here up to this index, nothing changes. Then we move here. Here it is a maximum bound, so we will update our maximum bound to 3. So now for that iteration it is also 0. Now when we come here, we see that which is maximum among 0 and what is minimum among these two. Minimum among these two is 1. And we have to subtract bad boundary. Bad boundary is still minus 1. So it will give us 0 comma 2. And which is maximum among these two? It is 2. So we get a 2. When we move here, the things remain same, nothing changes. So we again add a 2. But when we move here, our bad boundary gets updated. It will get updated to 5. Now when we see 0, which is minimum among these two, 1 and 3, 1 is minimum. And when we do 1 minus 5, we will get 0 comma minus 4, and a negative value is always less than 0. So maximum among these two is 0, so we will add a 0. So that is the whole point of this algorithm. As we have to find a subcontiguous array, we are always moving to the right side, and every index on the right side is greater than the previous one. So whenever the thing is out of bound, you will get a negative value, so you won't add that count, so you will simply add a 0 in that case. That is what I want to tell you. Then again when you move here, your maximum get updated to 6 but minimum remains same, so in that case bad boundary is also same, so that is also the same case, so you will get a plus 0 again. So the answer for this approach is 4. Let's see. 2135 is 1, 21352 is 2, then 135 is 3, and 1352 is 4. So total 4 arrays possible, that is our answer. So that is the whole approach of this question. You must try some different cases, then you can also think of this approach. The idea was that every element on right side will have a greater index, so we can subtract the bad boundary. And why are we taking minimum of these two? Because we have to know the starting index. Bad boundary is simply the index which is out of our bounds. So we will check, and whenever it is there, you won't add that array, you will simply add 0. That's what you have to do. Let's move on to the code and code this and check whether it is working or not. So let's make int b is equal to -1, max b is equal to -1, and bad boundary is also -1. And we have to make a variable long because we have to return long count. And simply as I told you, we will run a loop for int I is equal to 0, I less than num dot size, I plus plus. And what we will do, if our nums of I is less than minimum k, or our nums of I is greater than maximum k, that means we are out of bounds. So we will update our bad boundary to the ith index. As in this case, we was updating our ith boundary. Yes or no? When it is out of bounds. If it is not the case, what we will do? If nums of I is equal to min k, we update our minimum boundary to I. If nums of I is equal to max of k, then we update our max boundary to I. Now for the count part, what I told you, we will simply get maximum among 0 or the minimum of what? Min b or max b. That will tell you the starting index of the subarray. And you will subtract what? You will subtract the bad boundary from it, so you can get the number of counts. Finally, we will return the count. But before that, we made a mistake that we should add the count. We are adding it. Now let's just run it and check whether it is working or not. So yeah, it is running. Let's just submit it. So yeah, it is accepted as well. So the time complexity in this case is O of n, and the space complexity is also constant, or the space used to store the count of the number. That is all you have to do. I hope you liked the video. If you have any doubt, please comment down. Thank you so much for watching. Please like, share and subscribe. Bye bye.